The hearing is now back in session. We will now hear testimony from Mr. Phil Brooks, former Director of Engineering for OceanGate Incorporated. Mr. Brooks, I see that you have counsel present here in the courtroom. Counselor, can you identify yourself and your firm for the record?
Yes, good afternoon, Chairman. My name is Harold Malcolm, Lewis and Bacchius, and I'm here on behalf of Mr. Phil Brooks.
Thank you, sir. I think, we didn't have your microphone live. Can you just repeat?
Sure, absolutely. Good afternoon. My name is Harold Malkin, M-A-L-K-I-N, attorney with the law firm of Morgan, Lewis and Bacchius, and I'm here on behalf of Mr. Phil Brooks.
Thank you, sir. Mr. Brooks, at this time, the recorder will administer the oath.
Good afternoon, sir. Please stand and raise your right hand. A false statement given to an agency of the United States is punishable by fine and/or imprisonment under 18 USC 1001. Knowing this, do you solemnly swear that the information you're about to provide will be the truth, the whole truth, and nothing but the truth, so help you God?
I do swear.
Thank you very much. You may be seated.
Good afternoon, Mr. Brooks. My name is Jason Neubauer with the Marine Board, and we're going to start off today with Lieutenant Commander Williams, our engineer, with the first line of questioning, sir. If you ever need a break during the proceedings, just let us know and we'll take a recess, sir.
Good afternoon, Mr. Brooks. First, thank you for being here with us today. All of my questions are related to the time frame prior to the loss of the Titan, your background, and the experience you had working for OceanGate. We will explore the broad topic areas of the real-time monitoring system, third-scale model testing, specific dives and output data from those dives, and your reasons for departing OceanGate. To begin, can you describe your educational background?
Sure. So I have 2 degrees. I have an associate's degree from Edmonds College in electronics or electronics engineering. And then I also have a bachelor's degree in computer science from Seattle Pacific University. And my associate's degree was in 1982, and my bachelor's degree was in 1998.
Do you hold any professional licenses?
I do not.
Can you describe your relevant work history prior to working with OceanGate?
Sure. So the first part of my career was as a technician, and primarily in the field of medical equipment. So at the time that I earned my associate's degree, I was a technician for a medical ultrasound company called Advanced Technology Laboratories. They're now in Bothell, Washington. They are now part of Philips Medical Systems. And I was a shop technician and a service technician for about 3.5 years, servicing ultrasound equipment. After that, I became a field service engineer for a company called Marquette Electronics, and I traveled around the state of Washington and the Northwest, servicing mostly cardiac equipment in hospitals and installing equipment. From there, I went to a MRI company called Resonex, and originally I was a field service engineer servicing MRI systems, and then later became a technical support engineer in-house in Sunnyvale, California. And then I transitioned to being a software engineer around 1991 and started in the software group at that time. And that's when I started my bachelor's degree in computer science. So after Resonex went out of business, then I worked for a company that did vision systems, Mitutoyo, that makes vision systems and has to do with image processing. And I did software for them. And then I worked for a small company in downtown Seattle called Xides that did display driver technology. And then I worked one of my career accomplishments at Resonex was a patent for MRI kinematics, which is the motion study of MRI images. I did most of the software for that and some of the other techniques for MRI kinematics. So then after Xides, I went to work for a company called Olympic Medical, and for them I developed a EEG-based system, electroencephalograph, and it's called the Cerebral Function Monitor, and it's for monitoring a very specific type of EEG waveforms, mostly related to newborns and that sort of thing. But I did most of the software for them, became a very big product for that company. After that, let's see, I spent about 5 years in digital music, a company called DMX Music, and later MusicNet. And I did software related to music systems, music playback, so forth. And then after that, I worked for a company called Clever Devices when we moved to New York, and they were in transportation systems. It was specific to the transit industry, so like transit buses, and it was systems that monitor things like engine parameters and so forth. So after Clever Devices, I worked in the DoD industry for a while doing medical information systems, and these were research-related contracts doing research for medical information. And then I worked at Intel for about 3 years, and at Intel I was a memory systems engineer. After Intel, I went to Microsoft for a few years and did embedded systems for Microsoft. And then that takes me to OceanGate. And I started at OceanGate in 2019 and worked there until 2023. And at OceanGate, I started out as basically a Linux software engineer. And then in the fall of 2021, then after the engineering director left, then I was promoted to engineering director, and then I did that job. After that, I did primarily electrical systems and software both, so I had the dual role, but really specialized in software and electrical systems at OceanGate. At the time, I was concerned because I did not have a background in mechanical engineering or in materials, and the agreement was that other people at the company, mainly Stockton Rush and Bob Schuman, would handle those tasks, the mechanical engineering tasks and materials. And then at that point, the sub had been designed, so most of the improvements would be software and electrical related to navigation, that sort of thing, life support systems, life support monitoring. So primarily I focused on those tasks and not so much mechanical. A little bit of involvement with mechanical, but mostly software and electrical. So that's kind of a summary of my career.
The next set of questions will be related to the real-time monitoring system or the acoustic emission system.
Okay.
I'm going to use those terms probably interchangeably.
Okay.
Can you describe your involvement with the real-time monitoring system? What were your specific responsibilities?
So originally, when I started at OceanGate, they had the real-time monitoring system in place, and they had the hardware done, and for the most part, the hardware didn't change that much. The hardware had been designed by a board member whose name is Mike Ferlotti, and he was also a PhD in electrical engineering. So he designed the data acquisition hardware for both the acoustic monitoring and the strain. And so they had the system, and they were acquiring data. This was when the time that they were in the Bahamas doing the Bahamas dives, and I was asked to try and interpret the data from the Bahamas, and we could not really make sense of it. It just was not working. And so I realized the problem was that they were acquiring only the peaks of the data and not all of the data, so that only when data would go over a certain threshold would it be acquired into the system. And the problem is that you may get a peak of data at one time and then another peak an hour later, but in the stream of data in the file, those were right together. And then you may get a series of peaks very close together, like milliseconds, and then maybe another one an hour later, but those were all sequential in the file. So and they had no time tracking data or no depth data to correlate any of this to. So it was impossible to really analyze the data or really make any sense out of it, like what was happening at this time or at this depth. So basically redid all of the software. This would be probably, around fall of 2019 when I first started on this. And I redid the software to essentially acquire a full stream of data, and then from that, then plot it peaks and just everything. I also developed another technique. One of the problems is that the acquisition rate of the data is very high. At that time it was 500 kilohertz. So for an hour's worth of data, that's several gigabytes of data. And to try and plot it on like a piece of paper, just due to the averaging of printing, that you might lose a lot of peaks. So what I did was I developed a technique, I call it sample and hold, where I divided all the data into 100 millisecond intervals and then plot the maximum value from each 100 millisecond interval. And that became kind of the plotting form of data. So I had the original raw data and then the plot data. And then I could go back to the raw data and rescan that for different time interval or for hit counts and that sort of thing. Let me explain a little bit about hit counts in the AE science. That term is used quite a bit, and it's a threshold for what constitutes a amplitude rate that is significant. And it's done just by experimentation and determining what would be a low-level data or what actually constitutes maybe a fiber snapping. And so in our system, we were using A to D units, 0 to 32,000. So a hit was defined as 5,000. And on some studies, it was lower, it was 2,500. So that's very significant, is the hit counts. And I don't know if you've seen some of my plots, but there's amplitude plots, and then there's hit count plots, and then there's accumulation or cumulative hit count plots, which is where you see the plot rising and then it goes up higher, and it's always ascending, because maybe at the end of a study or end of a test that you may get thousands of hit counts. So that's another very standard thing. So by reorganizing the data and using this other technique, I was able to kind of make sense of the plots, and then we could then see, there's two common techniques in AE, or acoustic emission monitoring, and that's the Kaiser effect and the Felicity ratio. And the Kaiser effect, and they're really kind of the same thing. The Kaiser effect's a little simpler. It really says that if you see a burst of AE activity at a certain stress level, and then you go down or down to 0, then when you come back to that level, that you'll see very little. And it all gets into the idea that there's a seasoning of the carbon fiber, so that as you stress it, some fibers will break. And then once those fibers have broken, when you go back to that stress level, you don't want to see fibers breaking again. You want to see really no data until you go to the next higher level, and then you'll see a burst of activity. And then when you go down, and then you come back up, you'll see then low activity until you go to that next highest stress level. So after the changes to the software, we were really able to see the Kaiser effect and the Felicity ratio. The Felicity ratio it's really the same thing, but it has to do with a ratio of the higher stress level to the lower stress level. And so you want to see the number of fibers breaking to be under 90% from that next highest level. Does that make sense? Yeah, and I can get into this a little deeper if you want. I do have some graphs that I brought with me, and we can look at those if you want. But like I said, after making those changes, then we were really clearly able to see this phenomena taking place, and really see what we were getting on some of the pressure chamber tests and the dives.
Taking a step back, can you just talk me through some of the main components for a real-time monitoring system?
Sure. So there's really, I guess, three main systems. There's the data acquisition component, and these are sensors, and the company that makes them is a company called Mistras. It's a Greek company, and they make a whole variety of sensors, and they're basically microphones. And the sensors that we used was the R6S, I believe, sensors. They're a little bit lower frequency sensor, and these sensors are glued to the carbon fiber itself using typically RTV or silicone type glue. And then from there, it goes to a data acquisition hardware system. And really, for all practical purposes, you could think of this as being like an audio amplifier. It takes the data or the signal from these sensors, it amplifies it, and then it digitizes it, and then we get a stream of digitized data, digitized AE data that goes into a host computer, and then the host computer does the signal processing, and then the storage, and then later the display of the plots. Now there is another component to the real-time monitoring, and we had a real-time monitoring program that the pilot could watch. And what it is a series of bar graphs for each sensor, and then a total to the right of that was all sensors combined. And there was the instantaneous hit count or instantaneous amplitude, instantaneous hit count, and cumulative hit count for each sensor. And so they could see this kind of triplet of bar graphs that would be green, yellow, or red, depending on the parameters that we assigned. So that was the real-time monitoring software. And in addition, the total hit count was fed back to the control computer. And so on the main control computer, when they were driving the sub and looking at the compass and other navigation, there was another bar graph that showed the total cumulative hit count and also a green, yellow, or red indication if it had gone past our assigned threshold values. So those are kind of the components. And then the last part of that is the plotting software, that we would take the 100 millisecond data and the raw data and plot those on plots like you've probably seen. Let's see here, I've got, these are all strain plots, excuse me. Here's one here from DOTF. There's not much on it. And those were really the plots. Here's another one. This is from DOTF, and you can see low data here, and then as we go to this higher stress level, you see some bursts of AE activity. So these amplitude plots were a main component of how we assessed the hull after a dive or after a pressure test.
Mr. Brooks, for the record, I noticed that you were speaking from forms that you brought. Is it possible at the end of this that we could get copies of those forms?
Absolutely.
Thank you.
Yeah, absolutely.
Did you have any prior experience working with acoustic emission systems prior to working for OceanGate?
Not acoustic emission relating to materials testing. I had plenty of experience with data acquisition and music processing, as well as ultrasound and MRI, but not specific to materials testing. The signals are very similar, but I had not worked in materials testing before.
Can you describe the purpose of a real-time monitoring system?
So the purpose of the real-time monitoring system was that the pilot could assess the health of the hull as they descended, and if they saw a lot of AE activity, then they would drop the drop weights and surface. That was the designed intent of the real-time monitoring system. In addition to the AE data, there was also a strain data, and we had a real-time strain monitoring program as well, where the pilot could watch the levels of the strain gauges to see if there was movement in the strain gauges. And so that was part of the real-time monitoring as well, and a similar intent that they could abort the dive if things were not looking good.
Was this system the primary method for determining the health of the hull?
During a dive, yeah, the real-time monitoring system was the primary system. The plots were looked at after, in addition, to see if there was something that the real-time monitoring did not pick up. Obviously, we had the warning lights and the alarms, but they were running the sub and they were driving it, so they didn't have the ability to watch all three screens all the time. So that was the idea behind plotting and later analysis after the dive.
Those alarms, were they just visual or was there audible as well?
There were no audio alarms. We wanted to do that, and Stockton was totally against audio alarms. He didn't want them, but we wanted to do them, but we didn't. So.
And these screens, were they just visible by the pilot, or could the other crew members and mission specialists see them as well?
Everybody could see them. Since I wasn't really on very many of the dives, I don't know how much viewing was done. I think some, but they were really primarily for the pilot, but everybody could see them, if they wanted to, yeah.
You spoke earlier about acoustic hits and that being 5,000.
Yeah.
How was that level determined?
So we kind of came about these threshold levels through a whole bunch of tests. Initially, we took the Titan 1 hull to DOTF and we tested that. And then we did third scale hulls of the Titan 2 hull. And we just looked at the plots at first. We didn't really have the concept of a hit counter. I think we set it very low. We set it at maybe 1,000 or 2,500. And then we kind of came to the conclusion after looking at the data and looking at what constituted a clean hull, something like this is a clean test where, and I know it's hard to see, but the amp 5,000 is right about where my finger is. So there's a few coming up over that, but not very many. So it was empirical, just based on our gathering of data and looking at the data.
As you previously stated, we understand that you could see colors on board. Can you describe how that worked?
So we had assigned levels, and I may not remember all of the threshold levels for what was obviously below the warning. So there was a warning level and then an alarm level. And so the warning level would cause the bar to go yellow, and then the alarm level would cause it to go red. And so I believe that it was in the order of 30 to 40 was the warning level, and then over 50 was the red level. But I would have to go back and check the software to get those levels. So that would be cumulative hits.
And for those cumulative hits, was that all dives combined or just the current dive?
Just the current dive, yeah.
And for the yellow and red, so was there procedures for the sub to resurface at yellow, or was it just only if it hit a red color?
I believe if it hit red, if it hit the alarm level, then they would surface.
Are you aware of any time that the real-time monitoring system showed a color other than green?
There were a few times when I believe it went to either yellow or red. However, those were at the very end of a dive, and we did have an issue. I don't know if I have the plots with me, but at the end of the dive, they had to bring the sub up the ramp. And sometimes they would leave the acoustic monitoring left on they would be busy with other things and leave it on. And so as it came up the ramp, it was a bumpy ride, and that caused a lot of acoustic activity just from the mechanical, shaking of the sub. And I believe on some of those, it did go red, but they were not in the water, and they were on the surface. So those were reset. Those are the only ones that I know of. I don't know of any, like on the way down or at depth where it went to the alarm level.
And who determined the red, yellow, and green settings?
So primarily Stockton was the final say on that with our recommendations. I think we discussed this at several meetings and came up with these levels. By the way, in addition to the plots, there is the control log file, which logs all of the data from the control program. And in that file, there is the AE hits level. So those can be reviewed, and this question can be answered very accurately by reviewing the log files, in case I was wrong about this situation.
Was the real-time monitoring system only on or operational during dives?
Yes, yeah. That it was left off. Yeah, it was turned off when we were working on it, unless we were testing it. But they usually turned it on once they got underwater and started the dive. Yes.
Was there an operational requirement for the number of acoustic sensors or strain gauges that needed to be working prior to each dive?
So there were some that I don't know if any of the acoustic sensors failed during the mission, but there were some that had electrical noise on them. And so I don't know of any that failed outright. All 8 of them were working, but some of them had some low levels of acoustic or of electrical noise. And so we tried to fix that, and sometimes it would come and go. It's possible it could have been a cell phone or some other noisy piece of electronics. That was my only recollection of acoustic sensors not working. For the strain, there were three strain sensors that failed, that we could not get to, that they were under the insert. And so we had to dive with the remaining, 16. So I guess that would be 13 working strain sensors.
Was there a dive, no dive requirement for the number of acoustic emission sensors that were working?
Not to my knowledge. So in other words, you're asking if, say, 3 sensors failed, then would the dive be canceled? I was not aware of that, but like I said, I believe that they all were working. The ones that had electrical noise would still read acoustic data. They just had some low levels of noise in those lower amplitude levels.
Were the sensors regularly replaced?
No, we once we glued them in and installed the insert, then we did not replace them. They were there for the life of Titan. So yeah.
What tests were performed on the real-time monitoring system prior to each dive?
So the main test that we did an impact test, and what that is it's, if you think of it's like a spring-loaded hole punch that as you press it against the titanium ring, it would pop. And we expected to see a certain level of acoustic activity on the sensors. Before we put the insert in, when we were at DOTF, there's the standard pencil lead test. And you take I don't have one with me, but a mechanical pencil, and you actually snap the lead right next to the sensor. And then apparently this is used industry-wide. It gives off a very similar signal to carbon fiber snapping. And so we used the pencil lead test originally, but once we put the insert in, it covered up the sensors. So then we had to use this more, a much higher amount of mechanical activity, this pinger, to test to make sure that all the sensors were working. So that's how we tested it.
So prior to each dive, you would do this test?
Correct, yeah.
And who specifically programmed the set points for that yellow, green, red, or green, yellow, red system?
So those were done by the software team, which was myself and another person, Jerome Santos, and that there was a configuration file for the control program, and the configuration file had numerous parameters in it, and it had the threshold levels for the AE system in there.
And were these thresholds ever changed over time?
Not to my knowledge. I don't think we ever changed them. That they were the same through the duration of the Titanic expedition. They were tweaked a little bit early on, but once we got into doing the expedition and doing actual dives, man dives, they didn't change. They were the same.
Lieutenant Steele, could you please bring up Exhibit 058, the Titan AE and strain sensor layout, page 1? Mr. Brooks, have you seen this before?
Yes, I have seen this. Yes.
So
Is it-
there's one in the exhibit binder, and also we printed out an extra one for you right there. So the first page is what it's displayed, that one, yes.
Yeah.
And Lieutenant Commander Williams, what's the number of the tab, the exhibit?
It's 058.
Thank you.
Yes, I have seen this before, and I was comparing this to my notes. And I believe that there's a correction that needs to be made because probably what happened was from the time that this document was done, and then when we went to DOTF, which was fairly shortly thereafter, or possibly this was an error.
Mr. Brooks, could you, just because the board can't see what you're referring to, when you say this is an error, can you be
Yeah,
clear?
This document, I believe, is in error because the document that I have and the sensor placement that I remember is a little bit different. It's similar, but it's a little bit different.
And just for the record, he's referring to Exhibit 58, which he thinks may be inaccurate.
Thank you. So that document that you have in front of you was for the deep ocean testing facility, or the DOTF testing with the strain gauge and the acoustic emission sensor locations. If you have other documentation that shows something different, we would welcome that because we were hoping to correlate the strain gauge data and the acoustic emissions data to the actual locations on the hull.
Yes, and I will absolutely supply you guys with this document and other documents that I have, which show some differences in. I believe the placement is similar, but the numbering is different. So, and that's important because everything has to correlate. So,
Would a 10-minute recess to kind of go through some of that be helpful?
sure.
Okay, the hearing will recess and reconvene at 2:20. I just want to, before the question, we have received a document for Exhibit 56 with notations from Mr. Brooks. We are not going to present that at the hearing, but we're going to use that for our for analysis. However, this will be made Exhibit 56.1, and if I'm sorry, I stand corrected. This will be Exhibit 58.1. That will give some time to for everyone to review it before we enter it. But I think we can go on with the testimony without referencing the diagram with notations. Is that correct? And before we start, OceanGate, please.
Yeah, Mr. Newberman, I think we have located the document that this slide comes from. So if it would be helpful to the board, OceanGate can provide that document. So you have the full document of the 2021 DOTF testing as opposed to just a page.
I think that is part of the exhibit that we have.
I haven't seen it, so I don't know.
We did not deliver that to you in Homeport?
I mean, is there a way to see it? I don't, what,
Can we check the binder?
58, I thought we just added it.
We're not going to use the edited,
Well, but that's understood. What I'm saying is if the added exhibit, as I understand, is a one page that Mr. Brooks just turned over to you? Is that?
yes.
So my understanding from having looked at that page, that we actually have a full document that that page comes from, that we, OceanGate, can produce to the board, because it sounds like it would be helpful to your inquiry. And if that would be more helpful than entering one page out of that document that Mr. Brooks brought with him.
My understanding is that we have the full exhibit, and this will be just a correction to one page. But why don't we take a 10-minute recess? We'll reconvene at 2:40, just to make sure that, to match the exhibits, to make sure. Thank you. Okay, the hearing is now back in session. Just before we begin and reconvene with the questioning, after conferring, we will not enter a revision to Exhibit 58. Mr. Brooks has given some notes that everyone has reviewed. We now understand the correlations to the testing to the sensors on the drawing, and Exhibit 58 will stay as originally was submitted. Lieutenant Commander Williams, if you could continue.
So thank you, Mr. Brooks. Just for your awareness, we had interpreted the layout the same as you did. We just wanted to confirm the correlations. So what you provided confirmed how we were interpreting it. So thank you.
Absolutely, yeah. I understand how this came about without getting into too much detail, and so I did want to make a clarification. So I think we're all, on the right page now.
Yes.
Yeah.
So thank you. Going to switch topics just slightly, still talking about the real-time monitoring system, but can you describe the procedures for downloading the real-time monitoring data upon resurfacing?
So when the sub would resurface, that there were two sets of files so there were really, I guess, three sets. There was the strain data, which was just one file, and then there was the AE, I call plot data, which is the 100 millisecond sample data, and then the AE raw data. And so for presenting the plots, I would download the strain data and the AE 100 millisecond data, the plot data, and then go and produce all the plots. And it may have even been that the plots may have been done automatically. And I would typically redo them. And then usually every 3 or 4 dives, and this procedure to download the data was pretty simple. It was taking a portable drive, a portable USB drive, and we plugged it into we called it the data acquisition computer. It was separate from the control computer, and just downloaded the data, just dragged and dropped it over to the travel drive or to the portable USB drive, and then took that back to our computer room on the ship and loaded that onto that computer, and then did all the plots, and then emailed those to everybody. And that was the typical procedure after each dive. And then usually after every 3 or 4 dives, I would take another portable drive and then upload all the raw data. And those files were very large. They were several tens, I can't remember the exact size, but tens or possibly even hundreds of gigabytes. So it took quite a bit longer to upload those. And we had to do this to prevent the drive from filling up on the sub. So we would upload the raw data, make sure that it was correct, and then delete it off the sub, and then eventually upload that data to a server back at the Everett facility. In addition, the plot data, the strain and AE plot data, was loaded into our source code control cloud server. It's Bitbucket, and I believe that's still working today, so that these can all be accessed and downloaded from our Bitbucket server as well. In addition to the AE data and the strain data, I also did the same thing with the control log file. So those files are all on the Bitbucket site, and I reviewed the control or the log files as well.
What was the name of the Bitbinder server?
Oh, the Bitbucket server, I think it's Bitbucket by Atlassian it's similar to GitHub. If you've heard of GitHub, it's like a source code control cloud site. And so Bitbucket is like a analogy. It's kind of a competitor to GitHub. And that's what we use for all of our computer source code control and for these log files. And so there's an account. And to get to the account, you should have credentials. I know that my credentials still work, that I can still download data from it, so they never took my account off of there. But if you haven't been able to access that, I can absolutely help you do that. And then you can get all the data that I put on there. So.
Thank you. And just to confirm, someone on a vessel during a dive would not be able to see that real-time monitoring data. It would only be available after the dive was completed.
Yes, that's correct. Yeah.
Who was responsible for analyzing the data after each dive?
So I was the first person to look at it, and I immediately emailed it to Stockton, to Bob, and I believe I also emailed it to Mike Ferlotti, who was the board member who designed the hardware, and several other people, operations people, Jerome, the person that worked with me. I can't remember everybody who was on that list, but it was possibly 8 to 10 people that I emailed all this data to, the strain and AE data.
And who was the final authority for whether or not the hull was fit to dive again after analyzing that data?
That would be Stockton Rush, yes.
This next set of questions will be related to the third scale model testing prior to the second hull of the Titan and the testing that occurred on that Titan hull. When I say Titan hull for these questions, I am specifically talking about the second Titan hull.
Okay.
And the third scale models that supported that.
Okay.
Can you describe the testing that occurred on the second hull of the Titan submersible?
And so I assume that you're talking about the pressure test at DOTF, or Deep Ocean Test Facility, and the strain and AE tests, correct?
Yes, correct.
Yes. So there was a series, we went to the DOTF and we did 4 days of testing. And the first 2 days were specific to the Felicity ratio testing. So we had a test profile that mimicked Felicity ratio parameters. And then after those 2 days, then the third and fourth day, we went to the Titanic depth. So we went straight up to the Titanic depth, or straight down, I guess, and then held that for about 6-7 hours, and then back down to surface depth. And we did that for 2 days. And so that was the basic testing, pressure testing that we did for the full-size Titanic hull.
And were you there in person? Did you?
I was, yes.
Can you describe the third scale model testing?
Sure. So we did similar pressure testing for the third scale models. We built 2 of them. And I believe that the first date was July 26th in 2020. Yes, July 26, 2020. And the first scale model we tested to, I think it only made it to about 2,800 meters. We had a similar profile. I don't have those tests in front of me. I didn't get them, but I know that it failed, that we were, I think it was we would normally do an AM session and a PM session. So we would do a 4-hour test profile in the morning, and then after lunch we would do another 4-hour test. And I believe it was in the PM session that we got to, and I can't remember the exact depth, but it was probably around 2,800 meters. And all of a sudden we could see the strain start to move, and we could see the AE just go nuts, and then followed by an ear-splitting bang that was, ringing in the ears, and pretty catastrophic failure. When we brought the third scale model out of the test chamber, we had it enclosed in a Teflon bag to keep the shards of carbon fiber from damaging their test facility. And what had happened was that it had imploded inwards, and it had pulled that bag inside the third scale model. It was kind of interesting. Also interesting was that it did not break into shards, that there was just one tear that started out in the axial direction. It went about 10 inches and then went in the radial direction. So it was almost a right angle tear that ripped into this third scale hull. So that was the first test. The second, so we built a second third scale model, and we ran 2 tests on that. The first test did not work because we had a leak in the sealing of the end caps, and it kept leaking pressure, so we had to take it out and fix the leak. And that was done by a person named Kenny Haig, operations person. He fixed the leak on the second third scale hull. And then we went back, I believe, on August 20th of 2020, and we tested the second third scale model, and it actually did not make it to the rated depth that we wanted to. It made it to about the same depth, but it did not implode. Stockton, we would broadcast the computer screens via Zoom or Teams to Stockton's office, and so we were all watching in real time. And he had us bring down the pressure once it was very clear that it was starting to fail. So it didn't fail, but it didn't make it to the depth that we wanted it to. So we knew that we had to do something different because it wasn't working. The issue on those two, they were not multi-cure, they were just single cure, and we did not do the same technique that we did with the full-size hull, which was, like I said, the multi-cure and the after every cure smoothing out any bubbles or imperfections in each layer. So that's basically kind of the synopsis of the third scale testing, and there should be reports on that that are on the servers somewhere. I don't have them. I unfortunately didn't get those. I didn't get all of them, but there should be reports on those. So that's basically kind of the summary of the third scale testing. Yeah.
Do you know who built those third scale models?
So those were built by EI and wound at EI, and then they wound the cylinder, and then the end caps were glued on at the Everett shop. And that was operations. I think that was Kenny Haig and Ryan Stockfleet and maybe Travis Pickett that performed that. I didn't do it myself. I just installed the sensors, or myself and my team installed the sensors and installed the electronics and so forth. So,
And when you said EI, are you talking about electro impact?
correct, electro impact, yeah, apologies, yeah.
Where were these third scale tests conducted?
The third scale tests were done at the UW Oceanography Lab in Seattle.
And you already mentioned that these third scale models were not multi-cured. So was a third scale model ever constructed that was in the same layup or same type of manufacturing process as that of the full scale model?
No, yeah, we didn't do, we ended up not doing a multi-layer third scale hull. We went straight to the full-size hull and then did multi-cure on that, so, yeah.
So to confirm, there was no successful third scale model test to Titanic depth prior to going to this full scale?
That's
hull?
correct, that's correct.
Lieutenant Steele, could you please bring up Exhibit 66, acoustic emissions data for dive 77 through 83? Mr. Brooks, it might be easier for you to view them in the exhibit binder.
Okay.
So that's Exhibit 66.
So to go this way?
Commander Williams, can you clarify who did this report?
This report it takes the acoustic emissions data from dive 77 and 83, and we just put them all together in one exhibit. So it was put together by us, the Coast Guard, but it was pulling data from all of the RTM data that we had.
Yeah. Okay.
Are you familiar with these types of drawings? Or-
Yes, yes, I was the person that produced these plots, correct.
And Lieutenant Steele, you can just go through each one just slowly, so.
So, let's see, this is dive 77. So,
Can you just describe what you see in front of you?
yeah, that dive 77 looks, there's some problem here because let's see here, I don't see, so the depth is very shallow on the right side there. This may have been, dive 77 may have been,
If I may, Mr. Newbar, would
Sure.
it be helpful to Mr. Brooks to see the dive log and to kind of like place the date or something for the dive?
I think
instead of-
that's a good idea.
yeah, it's, it may have been like a dock dive or a, okay.
So we also have that dive log in the binder. So if
Okay.
you'd like to take that hard copy out and compare.
Okay.
Exhibit 82.
82.
Sorry, it's 52. I apologize.
Oh, 52.
For the record, Exhibit 52.
Okay. And,
And I'm sorry,
excuse me.
take me back to the other exhibit we were looking at.
66.
66.
Okay, yes, I see, it's Witless Bay, yeah. So that was a shallow dive, yeah. And that would explain why these look different than like a Titanic depth. Is that clear to you, to everyone? it's a shallow dive as opposed to a full depth dive. Yeah.
Yes, Lieutenant, so could you zoom out, just so we see all of the, can you just explain to us like what those purple lines are?
Yeah, like the bursts, look like bursts of AE activity, that,
We could go to dive 79, which is the first one to Titanic
full
on
depth.
this.
yeah, these were, I think what the end result is that the scaling, if you looked at the left-hand side,
Mr. Brooks, excuse me, we're looking at 79.
Okay,
not
okay.
77.
okay, 79, yep, okay. So, yeah, this is a much more representative, like a Titanic depth dive. And so here we see all of the channels, and in the blue is the depth profile, and then the purple is the AE activity. And as we can see, that so along the x-axis along the bottom is time, and then the intensity, and these plots have a dual y-axis scaling, because on the right side is depth, and on the left side is AE intensity. So I wanted to make that clarification, that that the depth, the blue line is representative in scale by the right side numbers, and then the purple is representative by the scaling on the left side, which is AE intensity or AE amplitude. And so here we see, and on some of these I know that they appear to be that scaling on mine is cut off, so we can't see it, but
Excuse me, does it make sense to pick a particular graph for dive 79 so we're all on the same page? And Mr. Brooks knows what he's describing and you all can follow specifically. We can move from one to the next, but I think it makes sense for everybody to be on the same page.
Yes, could you, Lieutenant Steele, could you zoom into the one on the upper left-hand side of the screen? Channel 4 specifically, so if you could.
Is that channel?
Go up just a little bit. Oh,
Goes to the next page.
that one.
that
Yes.
one
So
there?
yes.
Okay, yep. And this is a pretty typical profile for the Titanic depth dives. And so on the left side, you can see in a little bit, it has been cut off, but they're descending in depth. So when they reach that flat part of the depth profile, they're at Titanic depth. And then they surface, and they come up to surface level. So you can see that the purple peaks are all at the surface. The big purple peaks are all at the surface, and that's when it's going down up the ramp after they bring it back up on the ship. And that's what creates that AE activity, is the towing the submersible up the ramp, which was quite a bumpy ride, yeah.
And you did explain that earlier. Was this data ever taken into consideration, or because it had already surfaced?
I think because it had already surfaced, that it was known to be caused by mechanical jostling of the sub and not from the stress of the water pressure. So that was the.
So would it be fair to say that on the right side of that graph, that those data points were typically ignored with the analysis due to the mechanical
Correct.
or the location of the sub?
Correct, yes.
It might be easier for you just to look through each page, but I'm going to draw your attention to the acoustic emission sensors 1, 3, and 5, We noted that all three of these sensors for dive 77 through 83 exhibit the same characteristics of little to no activity compared to the other sensors that showed acoustic activity. I'm going to give you some time just to look at all three of those for all of the dives.
Let's see.
Which were the numbers again?
1, 3, and 5.
Okay, so,
And for your information, if it's hard to see, it goes in order. So the top would be 1, 2, the next line would be 3, 4, 5, and the,
Oh.
yes.
oh, okay, so 1, 3, 5, yep. That, yes, I do see that those had lower AE activity, but they did have some, and is the thinking that maybe they were not working, that I do remember doing my ping test and seeing amplitudes on all the channels. So that kind of confirmed for me that they were working. That some are definitely more sensitive than others based on their location, so.
We noted that even after the dive surfaced, there was no large acoustic emissions data for those 1, 3, and 5 sensors. Do you think that this little to no activity in AE sensors 1, 3, and 5 may indicate that they were not working properly?
It's possible. It's certainly within the realm of possibility that they were not working. I remember at the time that we did tests and confirmed that they were all working. So I don't remember any not being working, but it certainly is possible that could have happened.
And how would you know if the sensors were not working properly?
So the only way we really had to test them was the ping test, was using the pinger on the ring and to go at different positions and verify that we got a signal. So that was the test that we used, yeah.
Was there a certain level that you looked for in each sensor when you did that ping test?
I remember determining sort of empirically what that level should be for each ping, and I can't remember what those levels were at the time, but I do remember that some sensors did not respond as much as others, so that some were quite low if they were quite a ways away from where I was pinging. So yeah, that some were lower than others.
And during a dive, if a sensor was not working, would there be an error displayed for the pilot to see?
Probably not. You probably just would get no data on that sensor.
Were you aware of any acoustic anomalies that occurred either during any dive or upon surfacing?
So when you say acoustic anomalies,
Anything out of what was normal or for your average dive? Was there anything that just seemed out of place or abnormal?
And excuse me, when you say any dive, you mean starting when and ending when?
Any dive that Mr. Brooks was part of from the seasons of 2021 and 2022?
Thank you.
The only thing that I remember as being an issue was when we had the loud bang, and that we were pretty concerned about that, and that did produce AE activity. It was at the end of the dive after it had been on the surface for quite a while. It seemed like maybe 10 minutes or so, and that did produce quite a bit of AE activity. So there's that, and then I did have some concern in 2022. Let's see, if we go to 83, let's see, 1, 2, 3, dive 80. So if we look at sensor 4, that sensor 4 did have a characteristic of the kind of thing that we wanted to be concerned about, but it was never really that high. So if we look at sensor 4 for 83, 82, 81, you'll notice as it's going up to depth, or going down to depth, that we see some AE activity. And the issue is that it did not seem to be of the, crossing that 5,000 threshold that we had determined. It was just, I don't believe we saw that in 2021, and that's the reason I was concerned about that. But because it never got worse, and like I said, it never went beyond the threshold, then I don't think it was a concern. I know I did talk to Stockton about it, and so yeah.
So speaking specifically about dive 80 and that loud bang, what type of investigation was conducted after the dive to try to determine the cause of the loud bang?
So, well, of course, we did an inspection of the hull as best we could, but it's hard because there's the insert on the inside, and then of course it's covered on the outside. Really, the main thing that we did was look at the AE and strain data, but the strain data was kind of the main thing that we focused on for dive 80. And the strain data does show a shift in the level, and that's something that for me, and I want to preface this by saying that I'm not necessarily a strain expert or materials expert. I just have experience from what I saw from the third scale tests and the DOTF full-size hull tests, and what was normal and things that we found to be not normal. And a sudden shift in level was that's something to be concerned about, for sure. And we did see that it was fairly minor on, I believe, 2 of the strain channels, 2 out of the 16. And so that was the main kind of inspection that we did of the hull after dive 80. And I know discussed it with Stockton, and he wanted to continue on. That I think the plan was at that time to, let's dive again and see what happens on 81 on the next dives. And we didn't really see anything. We didn't see any further shifts in strain data. No loud bangs, nothing with the AE that really seemed out of the ordinary. So that was kind of the summary of what had happened with that issue.
So who made the decision to continue to resume diving operations after the report of the loud bang?
Definitely Stockton.
When you did the inspection of the hull, did you take off the fairing, or did you observe anyone taking off the fairing or removing the insert to inspect the hull?
I know we definitely did not take the insert out because that was never done. Fairings were routinely removed for maintenance, other types of maintenance on lights. And I believe that we did take the fairings off, but I'm not 100% sure. But my recollection was that we did. But that probably would be maybe better answered by some of the operations people.
Without taking out the insert, how much of the hull was visible for inspection?
So, you can take a flashlight and there's a small gap between the insert and the hull, and you can look down the length of the hull and inspect it that way, which we did. But it's not a great test. And I think you can only do that from the front, that you can't do it from the back, that it's blocked.
And is that the full 5 inches thickness of the hull? Or
No, it's not the full 5 inch thick, no, because that's would be a destructive test because the ring, the titanium ring, glues onto that 5-inch section. So to like look for delaminations, you'd have to pull the ring off. I think you have to saw it off, that glue doesn't come out. And that's how we did the Titan 1. That's how the rings were removed. They were sawed off, and then the rings were milled out. So yeah, it's pretty hard to inspect that inside the 5-inch section.
You mentioned looking at the strain data and the acoustic emissions data. Can you tell us more about the decision-making process for analyzing the data once it was downloaded?
So, like I said, I would prepare all the plots and then email them to Stockton, Bob, pretty much the whole team. And usually Stockton and I, went over it in private. And then I know that he looked at them, and I don't know how much, Bob was not on the ship, and I didn't really get much feedback from Bob. But really, it was really primarily Stockton's call. I would make recommendations, but it was really his call as to, if there was a cause for concern or if there was, we were going to maybe stop diving, that sort of thing. He pretty much had full control over that.
Do you feel with your background that you were qualified to determine what a shift in strain gauge data meant?
Probably not, no. That really should be referred to an expert in it, than somebody that had used strain gauges for, a period of time. I had a few years' experience with it, and I had researched it, and we had done plot to the actual physical distance. And I don't have that calculation with me, but we had gone through that process, to kind of validate what we were seeing. And so we needed to have an idea of knowing what we were seeing. And I know that was reviewed with Stockton and Bob. But I think the determination was for that dive 80 that was quite small. The level shift that we saw, or the amplitude shift, was a relatively small movement.
Do you know how a delamination or crack in the hull would show in strain gauge data?
I don't. Yeah, I don't have that XY comparison, whether it would show up as a shift. I know that I have strain data from the third scale hulls where we had, either imminent failure or problems, and that it's very obvious that there's something wrong, that you see. So what I looked for in strain data was the linearity with depth, that if it went nonlinear with the depth profile, that was something to be concerned about. And absolutely on the third scale tests, that it was as clear as day that you could see curves in the strain channels where the depth was constant, so the hull was moving, or a shift. It would go along and then all of a sudden shift to a much different level, so that possibly could have been a delamination, but something was clearly wrong, and it was a problem.
Was there any discussions about doing either or unmanned test dives after that?
No, there wasn't, yeah.
Was there any discussion of doing other sorts of non-destructive testing, like taking the sub back to the deep ocean testing facility to retest it?
I know we talked about that with Stockton, especially after 2022, that what we really wanted to do was bring the sub back at least to Everett and pull the insert and look at the inside of the hull to see if there were any cracks. And it was very frustrating because it was left in St. John's and left on the dock, and we had no way to work on it, no way to look at it. And we were told it was a cost issue, that the cost of shipping it back was prohibitive. They were low on money, And so, we couldn't do that. And really, that was basically around the time that I left, that it gotten quite frustrated with some of these issues and had decided to leave the company.
So to confirm, Stockton was aware of the concerns of this loud bang?
Oh, yeah. Yeah, oh, yeah, absolutely. Yeah.
Lieutenant Steele, could you bring up Exhibit 77? So this is just more specific on that dive 80, which you've already talked about, but we're going to talk about it just a little bit more in depth.
Mr. Neubauer, we've been going just about a little over an hour and a half. Would
Yes,
this be
sir.
a good time for a break?
Yes, let's take a recess and reconvene at 3:20.
Thank you.